This is a video for how to go about doing surveying field note calculations in Microsoft Excel for your civil engineering class. You will notice that I have set up a spreadsheet here of field notes where I show the back site, height of instrument, foresight, and elevation values that we will have underneath each of these columns. On the left, you'll see a benchmark, a turning point 1, a temporary benchmark, 2 other turning points, and a point of reference. I also have set up our top stadia and bottom stadia data over here that we will use from a presentation we're going to be referencing. So if you want to hit pause and open up Google Sheets or Microsoft Excel and kind of create for yourself a spreadsheet that looks kind of like this, this is kind of the flow of what I will do for today. So in our presentation, we're going to talk about differential leveling. And you'll notice in this picture, we have a tripod set up, and this is where our scope would be. And we're going to say our datum beginning point for elevation is going to be 0. Almost like we're going to say, sea level is at 0 right here. And when we come up and we have for ourselves a benchmark elevation of 350 feet, that's a height above sea level of where that benchmark is right here. And when we take a reading from our scope on our tripod, we note that it's 7.959 feet above the benchmark. So you'll notice this number here means our height above sea level for our tripod is 357.59 feet. That is the reading that we're taking from here because we see 7.59 on our telescoping rod over here. And we add that to this and we're saying, this is going to be, our height of instrument elevation. That's our ultimate height above sea level. When we turn the scope around 180 degrees and we see a foresight reading, you're going to notice that we're going uphill. So this number is pretty small in comparison to this number based upon the distance from here to here. So when we say backsight and foresight and temporary benchmark and turning points and things, this image right here gives a good idea of exactly what we're going to be referencing when we go through the spreadsheet and do the math. So I'm going to come back over to level loop. And notice in these little pictures here, you can see a tripod set up here and a tripod set up here. The temporary benchmark could be a pipe or a post. It's really just supposed to be a temporary place where you're getting a reading from. The benchmark over here is something that should be permanent and not moved. Sometimes you can find an actual benchmark with a reading above sea level in a community or certain places where you can actually take a 100% accurate reading from. There's also some apps on smartphones where you can find your elevation of sea level based on where you are. So you can see the tripod here is taking a backsight reading to the benchmark and a foresight reading to this turning point, which could just be somebody holding a telescoping rod next to some place that you just might be referencing. So that's a level loop for a closed circuit. In this case, we're going to say that the elevation, just to make it easier, the elevation of our where our tripod is standing or where our backsight stick is standing is going to be 100 feet. And we're going to say a reading that we took is 7.13 feet above 100. So when we go to find our height of instrument, we're just going to say equals, and we're going to tap on 100. We're going to say plus, and we're going to tap our backsight number, and we're going to hit enter. We get 107.13. Our foresight reading that we see right here is 4.26. It's a little bit of a smaller number, similar to the image we saw up here. So what we will do for elevation here is I'm going to say equals, and I'm going to tap on height of instrument, and I'm going to go minus the foresight reading and hit enter, and we'll get 102.87. So we have kind of set up for ourselves a nice little reference in Excel of where our unknowns are. So we have to do some math for our height of instrument. We have to do some math to find the elevations after each one of our foresight readings. What's nice about this, with the way I've set this up in Excel, is we can just go ahead and take our readings, our backsight readings, and write them down, and our foresight readings and write them down. And we can come into Excel, and Excel will start doing the math for us with how we have set up this spreadsheet. Given that I have all of these set up next to each other in columns, it's going to make this easy for Excel to read and understand. So what I'm going to do is I'm just going to scroll down to here. I'll stop right here real quick and see that they've come around and taken a reading at each one of these tripod scope readings from each one of these points. And you can see how we have these different turning points set up where each of these readings were taken. So if you got to the field and you write these down, you can actually just come back in and place them into your spreadsheets. One thing I'm going to do is I'm just going to kind of put this off to the side over here, and I'm going to start putting in, let's see here, 1.75. We got 5.62 and 0.94, so 5.62, 0.94. Going to come back here and we have 9.12. And we're done with it. We don't need a point of reference backsight. That's only going to be for foresight. And we're going to come back in here for foresight, and we have 2.99. That's another foresight reading. I'm just going to keep placing this in 6.01 and 7.98. 7.98, and I'm going to come back into here again and 3.34. 3.34. Now what's nice about this is, we already have functions in here. If you can see these functions that we've placed up here at the top. So all I have to do now is I'm just going to find this little black X right here, and I'm just going to drag down. And I'm going to let off, it's just going to say negative numbers because I haven't done these calculations. These calculations are dependent on these calculations. I'm just going to drag down and I'm going to let off. And you're going to notice that we have each of our readings that you can see that we've created right here. We have our original 100 and we have our 99.98 reading as our last reading. Now for closure error, we're going to say the final elevation minus your initial elevation. So we need to find what the closure error is. Again, we did a full loop and we want to find when we came back around, how close were we to being, 100% perfect? You're probably never going to be a totally perfect, but you're trying to say if you're within an acceptable amount of error. So for closure error, we're going to hit equals, and we're going to tap on 100, and we're going to say minus 99.98, and we're going to hit enter. And it's 0.02. That's our closure error. Now, for us to find the allowable amount of error, we're going to have to do some other math here. So one thing we have to find first is we have to find the total amount of feet we traveled in that closed circuit. Now, notice over here on the right, you have your top stadia and your bottom stadia reading over here of the back sight. And there's two different readings here, your foresight and your back sight reading for turning point 1 for your temporary benchmark for each one of these. And I've gone in and placed these. So if you want to hit pause and kind of put these in here, I've gone ahead and placed in these numbers just for the sake of time in the video that these were the readings that were taken when the telescoping rod turned. Remember, you're taking an elevation reading, a top stadia reading, and a bottom stadia reading every time that you look through the scope towards a benchmark, a turning point, or something like that. Now to calculate our distance, we hit equals and we're going to start parentheses. You're going to tap on bottom stadia, hit minus, tap on top stadia and hit minus, hit bottom stadia, close your parentheses and say times 100 and hit enter. And that distance from our benchmark to our scope was 300 feet. It's pretty accurate in how you go in and actually do that physically with an actual telescoping rod and an actual tripod and an actual scope. It's incredible how accurate the distance is. One of the things I do in my classes, we go out to a football field and it's perfectly 10 yards and then it's perfectly 20 yards and we just kind of get some benchmarks. That's how we lay out an X and Y grid when we first start learning this. Now, I don't feel like going and hit equals and doing everything over again, so I'm going to find my black plus and I'm just going to drag all the way down and let off. And it's going to do all those readings for me. Again, you need to have these set up in columns next to each other so it makes a logical sense to Excel. There's other ways to get around this, but it's a little more complicated. So for the sake of being, thorough, I like to set up my spreadsheets right next to each other. Now we need to add all these up so you can find 2,470 here. So I'm going to come back into here and I'm just going to go to auto sum and I'm going to hit enter. And auto sum automatically looks at the numbers right above it and it read the whole amount. So we have 2,470. What I need to do now is we're going to take 0.007 times the square root of the total number of feet divided by 100. So you will see that here to find a allowable error. So we're going to go into Excel and I'm going to say equals 0.007 times, I'm going to start parentheses, SQRT of, start parentheses, 2,470 divided by 100. Close parentheses twice, hit enter. We got 0.034. If we want to go ahead and round this up, we can come up here to the decreased decimal number. We got 0.035. The survey data is acceptable because it's within the allowable errors for closure error. Now, if you're going to actually go outside and actually do surveying, you want to, there's a, kind of a plumb bob you can put down to have it be perfectly right on top of something because every little increment counts with the more turning points that you have to make sure you have an acceptable amount of error, because you don't want to just be haphazard with every little place you set up. You want to be absolutely perfect with where you place everything. So this has been a video on how to go about doing height of instrument and elevation calculations, closure error calculations, your error calculations, and also your distance calculations for your field notes that you take when you do a project for your civil engineering class in Microsoft Excel.